Hello, how are you? How are you all? This lesson I am going to explain collision, which is lesson 6.3 in your textbook. The objectives of this lesson are going to be these objectives. First, you have to identify the different types of collisions. Second, you have to determine the changes in kinetic energy during perfectly inelastic collisions. Third, you have to compare the conservation of momentum and conservation of kinetic energy in perfectly inelastic and elastic collisions. And finally, like the previous lesson, you have to find the final velocity of an object in perfectly inelastic and elastic collisions. Okay. As usual, we have to come back to these objectives at the end of this lesson in order to check did we get them or not. Okay, so let's start. There are two types of collision. One is called elastic collision, the other is called inelastic collision. Elastic collision, you know, some objects are elastic. So elastic, like rubber objects, plastic objects are considered to be like elastic, like the collision between two balloons, for example. First of all, in all types of collision, we know that momentum is conserved. We said before, total momentum is conserved, neither created nor destroyed. So momentum is conserved in both cases. But the difference is in kinetic energy. For elastic collision, we consider kinetic energy to be conserved. So for balloons, for example, we consider that sound is very low, no heat, and no change in the object's shape. So in this case, it is considered as if kinetic energy before the collision is equal to the total kinetic energy after the collision. We can consider also billiard balls to be nearly elastic sometimes. Okay, يعني in this case we will consider the sound and heat to be very low. In inelastic collision, kinetic energy is not conserved because of heat and sound will be clear, like collision between two cars, okay, like collision between two glass cups, for example. Okay, there will be a deformation in the shape, okay, and a change in the shape. In this case, the kinetic energy before the collision for sure is going to be more than the kinetic energy after the collision. Why? Because some of the energy will be gone into heat and sound and, you know, due to the change in the shape. Again, for equations, we have to consider like something called perfectly elastic collision. So if we are going to have something which is perfectly elastic, yani as if kinetic energy is completely conserved. So as if we are considering no sound energy, no heat energy at all, and this is impossible, but we assume this, okay? So in this case, M1 V1 initial plus M2 V2 initial equal M1 V1 final plus M2 V2 final, which is the conservation of momentum. And you have to find kinetic energy initial. You know kinetic energy is half mv squared. So we have two masses, let's say, so half M1 V1 initial squared plus half M2 V2 initial squared. Don't forget the half and don't forget the square. Here, this is different than what did we take in the previous lesson. Then find the kinetic energy final, which is again half M1 V1 final squared plus half M2 V2 final squared. And you have to get that both kinetic energies are approximately equal. So kinetic energy initial is equal to kinetic energy final. Okay, no change in kinetic energy. What you are going to do is to find everyone separately. Find kinetic energy initial first and then find kinetic energy final, and you have to check if they are equal, then this is going to be perfectly elastic collision. For perfectly inelastic collision, we said inelastic collision means Momentum is conserved, but kinetic energy is not conserved. But there is something called perfectly inelastic collision. When we say perfectly inelastic collision, this means for sure that the two masses combine and move together after the collision. So M1 plus M2 into one single V final. Okay? So for perfectly, when we say in any question perfectly inelastic collision, this means that the two masses are moving together after the collision. So then we have to use this equation for conservation of momentum, which is M1 V1 initial plus M2 V2 initial is equal to take M1 plus M2 together into one single V final. Kinetic energy initial, still we have two initial velocities, so it is similar to this one, the same. I made an arrow here. So it is the same, half M1 V1 initial square plus half M2 V2 initial square. But the change is in here, in kinetic energy final. So it is going to be half into M1 plus M2 V final square. Okay. After counting the kinetic energy and initial and kinetic energy final, you will see that the kinetic energy final is less than the kinetic energy initial. So always we may ask about the decrease in kinetic energy or the energy loss. So the decrease in kinetic energy is going to be kinetic energy final minus kinetic energy initial, and this is going to be a negative answer. So why? Because it is an energy loss. Okay. So first of all, we have to focus on perfectly inelastic collision. Okay, we have to talk about perfectly inelastic collision, focus on these equations, and then we will continue with perfectly elastic collision. So let's focus on perfectly inelastic collision, yani the two masses combine together and move together after the collision, and to get kinetic energy initial this way, and then kinetic energy final this way, and then if the question is to find the decrease in kinetic energy, we subtract them. Okay, so let's go to the book and see the sample problem. So we are talking about collisions, and first we have to discuss perfectly inelastic collision, a collision in which two objects stick together after colliding. So here, the two objects are moving together after the collision with one single V final. This equation, M1 V1 initial plus M2 V2 initial equal M1 plus M2 into V final. So, sample problem. 1850 kilogram luxury sedan stopped at a traffic light. So, this is M1. Is 1850 kilogram stopped, يعني V1 initial is 0. Okay. Is struck from the rear by a compact car with a mass of 975 kilograms. So M2 is 975 kilogram. The two cars become entangled as a result of the collision. يعني they combine together or they stick together, move together. If the compact car was moving يعني before the collision at a velocity of 22 meters per second north, يعني positive. So V2 initial is 22 meters per second. How much is, the question is just about V final. يعني just to use this equation. M1 V1 initial plus M2 V2 initial equal M1 plus M2 into V final. يعني here this practice, the question is just, let's look at the practice. Please all, you see this practice again. I will go back to the sample problem, don't worry. 1500 kilogram car, so this is M1 at 15 meter per second south, so negative 15 meter per second V1 initial, collides with 4500 kilogram M2, initially at rest, V2 initial is 0, the car and the truck stick together, move together, what is the final velocity? See here, what is the final speed? See here, what is the velocity of the joint cars after the collision, etc., etc. So questions are just to find the final velocity and to use the equation, which is M1 V1 initial plus M2 V2 initial equal M1 plus M2 together V final. I will focus on the sample problem and do question number 5 with you, and so you can do the other questions. Let's go. Okay, keep it. Okay, and here, page 207 in your textbook, M1, I am showing you the book, you see, I am showing you the book, the textbook, so that if you left, some of you left their books in the school, so you can see the questions from the lesson itself. So M1 is 0.5 kilogram, M2, sorry, not this one, I'm sorry. Okay, I will come back to this one, but now we are in here. Yeah, let me go back to the sample problem. So here the sample problem, what we are going to do, so V final is equal to M1 V1 initial plus M2 V2 initial over the total mass, which is M1 plus M2. So M1 is 1850 times V1 initial, which is 0. So anything times 0 is 0, plus M2, which is 975 times the V2 initial, which is 22, over the total mass, which is 1850 plus 975, and you are going to get 7.59 or 7.6 meter per second to the north. Let me give you one more example. As I told you, I will go directly to question number 5. A 47.4 kilogram student runs down a sidewalk and jumps with a horizontal speed of 4.2 meter per second into a stationary skateboard. So this is going to be M1, and I have to consider, since jumps down, so I have to consider this V1 initial to be negative 4.2 meter per second. Stationary skateboard, so the skateboard, the V2 initial is 0. The student and the skateboard move down the sidewalk with a speed of 3.95 meter per second. Now, V final is given. They both go with the 3.95 meter per second, still moving down. So I will consider it also as to be negative. The question is what left the mass of the skateboard. M2 is not given. So we have to find the mass of the skateboard, and we have to find how fast is the student would have to jump to have a final speed of 5 meter per second. So if I change the final speed, instead of 3.95, after knowing the mass of the skateboard, then what will be the initial velocity of the student to get final speed of 5 instead of the 3.95? Yani this 4.2 meter per second has to change. How much is its value? So let's see. Okay, let's come back to the E-class. Okay, so here we have M1 47.4 kilogram, V1 initial, I told you I have to take it as negative 4.2 meter per second. V2 initial is 0, stationary. They both go with one single V final, and it is also down, so minus 3.95 meter per second. The question is to find M2. So I used my equation, my single equation in perfectly inelastic collision, which is M1 V1 initial plus M2 V2 initial equal M1 plus M2 V final. Now this is 0. Why? Because anything times 0 is 0. M1 is 47.4, V1 initial minus 4.2. Here 47.4 plus M2 into minus 3.95. What I am going to do is to divide. Let me cancel this minus 3.95. Divide both sides. Okay, so I will remain here with 47.4 plus M2. Okay, and this much, which is 47.4 times minus 4.2 over minus 3.95, I will get 50.4. If I take 47.4 to the other side, it will become negative 50.4 minus 47.4. The mass of the skateboard is going to be 3 kilograms. Now we know the mass of the skateboard now. So let's see if the final velocity, instead of being minus 3.5, become minus 5. How will the V1 initial change? So again, the same equation, M1 V1 initial plus M2 V2 initial equal M1 plus M2 V final. but now M2 is known. خلاص. M1 plus M2, which is 3, into V final, which is -5. And here 47.4, how much is the new V1 initial? Do the calculation, you will get -5.31 meter per second. What did I do here is that all questions from 1 to 4, I wrote for you the answers. Here are the answers of the questions from 1 to 4. Questions from 1 to 4, we are going to find? V final. Use just this equation and find V final, which is very easy. Okay. Now let's come to energy. Okay. From now, let's continue with energy. Now, what if the question here, since it is perfectly inelastic collision, what if the question will be like, what is the decrease in kinetic energy? So how can we find the decrease in kinetic energy? So here, if we go back, so what do I have to find? I have to find kinetic energy initial, which is half M1 V1 initial square plus half M2 V2 initial square, and then find kinetic energy final, which is half M into M1 plus M2 V final square, and then subtract them. 3 steps. Let's do them. Sorry, where are we? Here, yeah. So let's do them. Kinetic energy initial, half M1 V1 initial square plus half M2 V2 initial square. V2 initial is 0, so anything times 0 is 0. This factor will be cancelled. Half M1, which is 47.4, times, I'm talking about part A, V1 initial, which was minus 3.95. In bracket, if the velocity is negative, please put it in bracket and put the square outside the bracket. So minus 3.95 in bracket squared, I will get 4.18 times 10 to the 2 joules. Kinetic energy final, half M1 plus M2, 47.4 plus 3, times V final, which was how much? Which was minus 3.95. Sorry, here it was minus 4.2. Sorry. V1 initial was minus 4.2 square, and here minus 3.95 square. Minus 3.95 in bracket square outside, here minus 4.2 in bracket square outside. I will get 3.93 times 10 to the 2 joules. Subtract this minus this. Kinetic energy final minus kinetic energy initial. You will get a negative answer, which is minus 2.48 times 10 to the 1 joules. More problems. Let me go back to the book. Also, there are extra problems here concerning perfectly inelastic collision, which is this one. They did as if in the book one practice just to practice the first equation, which is M1 V1 final plus M2 V2, M1 V1 initial plus M2 V2 initial into equal into M1 plus M2 V final, just this equation. And here another practice to practice everything. V final and kinetic energy. So let's see, like here. So sample problem F, 2 clay balls collides head on in a perfectly inelastic collision. We are here about in page 208. We'll see after a while. Okay. The first ball has a mass of 0.5 kilograms, so this is going to be M1. Initial velocity 4 meters per second to the right. This is going to be V1 initial. The second ball 0.25 kilogram M2, initial velocity 3 to the left, so minus 3, V2 initial. The question is, find the decrease in kinetic energy. You have to find V final first using the first equation, and then you have to find the decrease in kinetic energy using the 3 steps that we talked about. Kinetic energy initial, then kinetic energy final, then subtract. I will come back to this simple problem, don't worry. But let me show you something here. You see here in the practice the same question. Look, part A, what is the final velocity? What is the decrease in kinetic energy? Here, part A, question 2, what is the final velocity? What is the decrease in kinetic energy? Question 3, what is the final velocity? What is the decrease in kinetic energy? So copy paste on the sample problem. Let me go to the sample problem and show you, and I will give you the answers, and then you have to do the questions, the other questions. So here, page 207, we are in page 207. M1 is 0.5 kilogram, M2 is 0.25 kilogram. We said V1 initial is 4, V2 initial is -3. First of all, I have to find V final. Why? I use it here. Okay, I need it here. So I have to find the V final. So M1 0.5, V1 initial 4, M2 0.25, V2 initial -3. M1 plus M2 0.5 plus 0.25, and we have to find V final. 0.5 times 4 is 2, 0.25 times -3 minus 0.75, 0.5 plus 0.25, 0.75 V final. 2 minus 0.75 is 1.25, divide 0.75, I will get 1.67. So V final is 1.67 meter per second. Kinetic energy initial, you know, we did before 2 minutes. Again, half M1 V1 initial square plus half M2 V2 initial square. Everything is given. So it is 5.1 joules. Do the calculation, please. And then you see here, -3. I put it in brackets, square outside. Kinetic energy final, both masses together. V final separately, it's one single V final square. I get V final, kinetic energy final, and then subtract them to get the decrease in kinetic energy. Here, all students, please, are the practice, the answers of the practice in page 208. V final, get kinetic energy initial, get kinetic energy final, subtract. V final, kinetic energy initial, kinetic energy final, subtract. You know how, similar to here, everything is done for you here. Sample problem is done for you. And here are the answers. This for question 3. Please try to do them. The answers available, you can check. Okay, let me continue. Now I will go to elastic collision. Let's go to elastic collision now. For elastic collision, it is going to be in here, elastic collision. Remember, for elastic collision, a collision in which the total momentum and the total kinetic energy are conserved. We said as if no heat, no sound. You see here, most collisions are neither elastic nor perfectly inelastic. Why? Because we said that for elastic, there still be some sound, some heat, a little bit sound, a little bit heat. And for perfectly inelastic, when they combine, okay, still they will not combine completely, and we can't get the total mass completely. Okay, here are the equations. I told you for conservation of kinetic energy, don't do like this and put them equal to each other. No, we have to do them separately. We have to get kinetic energy initial first, then kinetic energy final, and then check if they are equal or not. Let's see here the sample problem. I think it is in page 209. A 0.015 kilogram marble, so this is M1, moving to the right with 0.225 meter per second, V1 initial, enters into an elastic head-on collision, so it is given elastic with 0.03 kilogram M2, moving to the left with 0.18, so V2 initial negative 0.18, it is clear here. After the collision, now we are going to talk about V1 final and V2 final. So when we say after the collision, yani final, the smaller marble, which is this one, yani M1, is moving to the left. So V1 final is minus 0.315 meter per second. Question is, what is the final velocity V2 final? So I use the whole equation, the long equation. I will show you in the E-class after a while. And then they asked here to verify kinetic energy. And let me show you also the practice in page 210. I will come back to the sample problem, don't worry. But here, let me show you also here again, find the final velocity, verify your answer, find the velocity, verify your answer. Yani they will ask you about one of the velocities available or maybe one of the masses, and then part B always is going to be for elastic collision, verify the elasticity of the collision. Okay, so let's go and come back to the sample problem. So we said for sample problem that M1 is 0.015 kilogram, V1 initial is given, M2, V2 initial also, V1 final, we talked about them. Now the question was to find V2 final. So put the long equation, do the calculation as you see. Okay, don't forget, get this answer, use your calculator to do everything here. You will get a negative answer here. And then multiply this times negative 0.315, you will get an answer here, plus 0.03 V2 final. What we are going to do here, shall we add these two? No. Why? Because here we have an unknown. So we have to take the number to the side of the other number. This is minus. When I take it to the other side, become plus. So 4.725 times 10 negative 3 minus this much, I will get 2.7 times 10 negative 3. This much is equal to 0.03 V2 final. Divide 0.03 to get V2 final. I get it as 0.09 meter per second. Then part B, to verify the kinetic energy conservation, do the conservation of energy and find kinetic energy initial using this equation, find kinetic energy final now using this equation. The two V finals now are separate. So every mass has its own V final velocity. You know, this was V1 final and we get V2 final. And here, please be careful, if the velocity is negative, put it in bracket, square outside bracket. I am getting here 8.66 times 10 negative 4 joules, and also for kinetic energy final, the same answer. So I am sure now that the collision is elastic, perfectly elastic. Why? Because the kinetic energy is conserved. Okay. Now here in page 211, I did also question number 2 for you. And also I did number 4. Let me show you. Let's go back to the book. In question 2, 16 kilogram canoe moving to the left with a 12.5 meter per second. So M1 and V1 initial is negative 12.5. Enters into an elastic head-on collision with 14 kilograms. So this is M2. Moving to the right with 16, so V2 initial. Now after the collision, the raft moves to the left with 14.4. The raft, which we call it M2. So which means V2 final is minus 14.4 meter per second. Find the velocity of the canoe, which was M1. So we have to find V1 after the collision, so V1 final. And then we have to verify the answer. Okay, let's go and see. So everything here, the given available, we have to find V1 final as we said, and then we have to verify. Use the equation. Okay, I'm replacing everything as you see. Do the calculation, do everything here, one number, and take the number towards the number as we did in the previous question. I will get here minus 201.6, take it to the other side, become positive. Then divide by 16, you will get V1 final to be as approximately 14.1 meter per second. Then do kinetic energy initial, you see. Do kinetic energy final. You will see that they are going to be equal. Here are answers for question 3. Please check. You can do yourself. And let me do with you number 4. A 25 kilogram bumper car moving to the right at 5. So M1 25 kilogram and V1 initial is 5. Overtakes and collides elastically with a 35 kilogram bumper car moving to the right, but without giving us its velocity. So M1, V1 initial, M2, no V2 initial right now. After the collision, now we are talking about final, the 25 kilogram, which is M1, is moving with 1.5 meter per second to the right, so this is going to be V1 final, and the 35 kilogram moves with 4.5 meter per second to the right. So this is going to be V2 final. So M1, M2, V1 initial, V1 final, and V2 final. What left? V2 initial. So find the velocity of the 35 kilogram, which is M2. Yani we have to find V2 before the collision, so V2 initial. And then we have to verify. Let's go. Okay, we are in here. So M1 25 kilogram, M2 35 kilogram, V1 initial 5, V2 initial unknown, V1 final 1.5, V2 final 4.5. Write the whole equation. Okay, the original equation, the one that we took in the previous lesson, and it was the conservation of momentum law. 25 times 5 plus 35 times V2 initial equal 25 times 1.5 plus 35 times 4.5. 25 times 5 is 125. 35 V2 initial, and here everything will get 195. Take 125 to the other side, so 195 minus 125, I will get 70. 35 V2 initial is equal to 70 over 35 over 35, so V2 initial is going to be 2 meter per second. Then find kinetic energy initial. Use this equation. Don't forget the half, don't forget the square for each. And if negative, please put it in bracket, square outside bracket. I will get 382.5 joules. Do for kinetic energy final the same thing. Again, 382.5 joules, so they are equal, so the collision is elastic. If in the question they ask us, for example, to find V2 final, and they are saying that the collision is elastic, then you can use kinetic energy initial, find the answer, and you can say kinetic energy final is the same thing. But if the question is to verify, you have to do them separately. Okay? So let me show you, like in the previous lesson, an MCQ question in order to check yourself at the end if you can do. Here also MCQ questions about the collision. Okay. 20 kilogram shopping cart moving at a velocity of 0.5 meter per second collides with a store wall and stops. The momentum of the shopping cart, what will happen to it? It was moving and then stops. Yani, we are talking about the momentum of the shopping cart only. Initially, it was moving with 0.5 meter per second, so there was a momentum. But finally, it stops, so V final is 0, so its momentum decreases. Okay, do the other questions, please. Try to do the other questions, please. For example, here 6, let me do with you more questions. In two-body collision, momentum is always conserved, kinetic energy is always conserved, neither momentum nor kinetic energy is conserved. Both momentum and kinetic energy are always conserved. In two-body collision, we said, no, we have different types. So momentum is always conserved. We can say kinetic energy is always conserved. We can say momentum is not conserved, and we can say that both are not conserved. So the answer is A. Then here we have 7 to 11. Okay. And then 11 to 15. For example, let me check with you number 13. two balls of dove collide and stick together, identify the type of collision. Since they stick together, remember we said the type of collision is going to be perfectly inelastic collision. Okay. Let me check with you number 17, the last question, which of the following best describes the momentum of two bodies after two-body collision if the kinetic energy of the system is conserved? Okay. What about the momentum? If kinetic energy is conserved, what about the momentum? We said that momentum is conserved from the previous lesson. Okay, neither created nor destroyed. So must also be conserved. Please, as I told you for the previous lesson, please check these links. They are videos about collision, one about inelastic, one about elastic, one about I think exercises. Please try to watch them in order to get more concept about the lesson. Finally, let's come back now to the objectives again. So, do you know from now on how to identify the different types of collision? I hope, yes. Do you know how to determine the changes in kinetic energy during the perfectly inelastic collision, which means the decrease in kinetic energy, the energy loss? I hope, yes. Do you know how to compare the conservation of momentum and conservation of kinetic energy in perfectly inelastic and inelastic? How are they in perfectly inelastic and how are they in elastic? And finally, do you know how to find the final velocity in perfectly inelastic and inelastic? And maybe not necessary to be the final velocity, maybe the final velocities may be given and how to find initial velocity or mass. We did many exercises and I hope you got all of them. Thank you very much. See you next lesson. Bye.